Good morning, everyone. So the last time we left off, we were taking a look at these natural logarithms, or using this number e as our base. Now, last time I made this video, I talked to you guys about how to evaluate when the base was e, or it was a natural log, and that like expanding and condensing were the same rules. Now, pause your video and try this warm-up. You're not trying it, you're just waiting for me to do it. Are you trying it? Did you try it? Now you want to see how to do it? Okay, so when we go ahead and we do a problem like this, oh, my pens seem to have this, oh, there they are. What you guys are going to do first, with your law of logs, if you have a coefficient, the coefficient when you are condensing comes back as an exponent. So these are each now the natural log of x cubed plus the natural log of y squared. Now, in the directions here, it says a single logarithm. That means you're going to see the word log or natural log or ln written one time. So when I have the sum of two logs, that condenses with multiplication. So I'm going to end up with this natural log one time, and then I have x cubed y squared, a single logarithm. Now, when you guys are expanding, right now I have a single logarithm, and it's the log of a fraction. And so when you have a log of the fraction, that means that it's going to turn into subtraction. So the first thing I'm going to do is I'm going to rewrite this as the natural log of e to the fifth minus the natural log of y. Now, if you get to this point, you're doing pretty good. But this also tells us to evaluate when possible. Now, when I saw you guys last via my lovely video here, these were these properties of logs that we looked at. And so if you take the natural log of e, well, that's just going to be 1. But here I have the natural log of e to the fifth. So if you look at this third property, that's telling us that we have 5 minus the natural log of y. And so this is the explicitly expanded conform. My daughter is holding a giant donut in her hands right now, trying to let her eat it. I'll be back for the next view. Okay, so now what we're going to do is we're going to look at how to solve a log equation when it's a natural log. Now, when I was grading the quizzes, I haven't finished everybody's that little mini quiz. You guys did really good on solving the log equations. So these are actually going to be the same process, and I'm only going to go through one type of them with you. And that's going to be when we have a log equal to a number, but when it's a natural log equal to a number. Now, when it's a natural log equal to a number, the first thing that you guys need to do, if it's not already, is condense to a single log. Well, it's condensed to a single log. Now, in this next part, there's two ways to think about it. One of them is to say, I'm going to switch this so that it is in exponential form. Well, so remember, down here, we have that hidden base. That hidden base, remember, is the number e. So if you guys were going to canoe this to switch it to exponential form, we end up with e to the third equals x. And well, e to the third is a number, and x has been solved for. It is by itself. So this would be the exact solution to the problem. Now, in our next one, I have the natural log of 5 plus the natural log of x. So I have the sum of two logs, and so I have two logs. I need to condense it. And so if it's addition, it condenses with multiplication. Now, we're going to do the same thing, though. Once you guys have it condensed to a single log, then you guys need to change, well, bring it down so you can see it, to exponential form. You need to canoe it. So we end up with e to the 7th equals 5x. Well, I'm solving an equation. I have to get x by itself. So in order for me to get x by itself, I'm going to divide both sides by 5. So my solution is x equals e to the 7th over 5. And again, this is the exact solution. If you want it approximate, you could just go ahead and plug it into your calculator and look at the decimal. Okay, and then for our last one here, we end up with 2 natural log of 3x plus 5 equals 4. So there's going to be a few different ways that you guys can do this one. I have preferences, obviously. Now, so what we need to talk about is this 2. Because it's a single log, but I have something outside of my logarithm on that same side. So I have two options. I could take this and I could bring it back as an exponent. But honestly, the easier thing here to get that log by itself would be to divide both sides by 2. So we're left with the natural log of 3x plus 5 equals 2. So now that that's done, I can go ahead and I can switch it so that it's in exponential form. Do that little canoe thing we do. So I end up with e squared equals 3x plus 5. Well, e squared's a number. Leave it. I can subtract 5. So now I have e squared minus 5 equals 3x. And then I can go ahead and I can divide both sides by 3. And so this is the solution. Now, the one thing I want you guys to know about that solution is if you are looking for a decimal approximation and you want to plug it into your calculator, you've got to put that numerator in parentheses, or when you enter the numerator, hit enter, then divide by 3, or else it'll jack up your order of operations. All right. Now, this is the second part of this lesson in which we're going to solve exponential equations that have a base of e. Now, you guys have solved exponential equations before. You had problems before that looked like 2 to the x equals 8, and you knew that you could rewrite 8 as a base of 2, so you'd have 2 to the 3rd equals 2 to the x, and then you could say, hey, x equals 3. Or if you had situations like this, in which you knew 5 is not a power of 2, so that method not going to work. And that what you could do here is you could take the log of both sides, move the x, so we end up with x log of 2 equals log of 5, and then divide both sides by log of 2. You need help with something? And now that I've helped her with something and totally lost track of where I was, here we are. So here we end up with x equals log of 5 divided by log of 2. So let's take a look over here at this problem. We have 2e to the x equals 8. So the first thing that you guys need to do is isolate the variable and its base. So this x only belongs to the e. So I'm going to divide both sides by 2, and I get e to the x equals 4. Now, once you've isolated the exponent and its base, in this case the e to the x, then you guys want to take the natural log of both sides. Hold on, someone needs a ponytail. Say hi, Joey.
Hi.
It's her dad's birthday today, and he just left for physical therapy, so she's trying to get all ready because we're gonna make some cupcakes soon. I know sometimes the words get stuck, right? Cupcake. Good job. And decorate with frosting. So where I was, we have e to the x equals 4. So now I'm going to take the natural log of both sides. Now, when I go ahead and I take the natural log of both sides, this is going to be the natural log of e to the x equals the natural log of 4. Well, the natural log of e to the x equals x. So now we have the natural log of 4. And that is the exact answer. If I had my calculator, I'd plug it into the calculator to show you how to do it. There's an LN button on the left-hand side. Hit that button, type in 4, you'll get your approximate answer. So the answer is a decimal. Okay, so in this problem, still gotta isolate. And when we do that, we end up with e to the 3x equals 10. So when I go ahead and I take the natural log of both sides, natural log of e to the 3x. This is just 3x. We end up with 3x equals the natural log of 10. Divide both sides by 3. And I have x equals the natural log of 10 over 3. Okay, and then here is your final one. So I'm actually going to modify this a little so I can show you guys something. Okay, I'm going to put that 1 there. There we go, folks. All right, so first thing, got to isolate that. So I'm going to subtract 2. All right, but I still have this 4 up front. So if I divide both sides by 4, now I'm left with e to the 2x minus 1 equals 7/2. So now that this has been isolated, I am going to take the natural log of both sides. I'm getting hugs. All right, so the natural log of both sides, then the natural log of e to the 2x minus 1 just becomes 2x minus 1 equals the natural log of 7/2. So this is when you have to be careful kind of with the way that you write it. If I'm solving for x now, I am going to add 1 to the other side. But when I add my 1 to the other side, I'm putting it in front of the natural log of 7/2, so I don't think I'm actually taking the natural log of the 1 as well. And last but not least, I'm going to go ahead and I have 2x equals 1 plus the natural log of 7/2. So I can just divide both sides by 2. The problem is when I put it into my calculator, that's going to make things a little more challenging. So it's not wrong to do it that way, but I would suggest putting the parentheses here and then the 1/2 on the outside. So this is the last day of like solving these equations and all this stuff. And then we're going to start taking a look at some of the applications and looking at something called a geometric sequence that we can use this with. All right. Have a good one, everyone.